C++ Programming Comprehensive, Chapter 1, Continuation, Start Unit 5. In this unit, we will look into how the scoping rules apply to the C++ program. So the declarations and scoping of identifiers. Basically, identifiers are the variables that must be declared for them to be available within the scope. So that declaration of variable can be done any place within a block. In C++, there is no restriction. Within a function, you can declare a variable any place that you like. So whenever you declare a variable, that's the time the memory is allocated for that particular variable. Within a C code, within a C programming language, the variable declaration must be done before or as soon as you start the function. So that's the one major difference between C++ and C. So within a block in C++, you can declare a variable and then have a statement and then declare a variable and then have a statement. But you can't do that same thing in a C programming or in a C code. So every identifier declared has a scope. So scope meaning that within that's the time that will be available within the memory. Whenever the identifier is in the scope, that means it is available from the memory within that block. So the scope of the declared variable extends to the end of a block. So basically, a block would be a left curly braces, and the end of a block would be a right curly braces. So within that, if you declare any identifier, the scope will stay within that block. As soon as you exit the block or come out of the block, then that identifier disappears or the memory is released. Okay, so that's why the scope extends till the end of the block, meaning right before the right curly braces. So scope is a portion of a program in which identifiers can be used to access the data objects. Since the data is in the memory, okay, and if the identifier is not going to be in the scope, that means the data will be released. Okay, so you would not be able to access anything from that memory location. So let's see the example that will make you understand how these scoping rules are used in C++. Line number 0. I have line number 0 because I'm using a cout object. Okay, IOStream header file must be included every program where you want to be able to have access of a cout object. Line number 1. A prototype for a show function. Okay, in this case, the return type of a show function is a void. Now notice that this is a standalone program. It doesn't have any class concepts or nothing. Okay, so this function is a global function basically. It doesn't belong to any class. The function body is on the next page. And at line number 2, I'm declaring a global variable. Now also notice I say it's not a good idea. This is just for you to understand the scoping rule. That is the reason that I'm declaring the global variables. Okay, so within this program you will see that I will be utilizing this global variable. At line number 4, I'm starting the main. The beginning of the main occurs from line number 5, the left curly braces. Okay, and at line number 6 I am using a cout object, and as we have already talked about, std, which is a namespace, that's where the cout object is. Okay, we are telling the cout object to display this string total cats. Okay, so in this case, and cats, we already have declared it at line number 2. Okay, so that is a global variable. So whatever is that and cats is initialized at line number 2, which is 20, that 20 will be displayed at line number 6 once after you compile the code. At line number 7, as I was telling you when we were going over the bullets, that you can have in C++ mix the declaration and then the statement. So at line number 6 is a statement, line number 7 is a declaration of the variable. You can't do that in C language. So at line number 7 I am creating or allocating the memory for the variable called ntcats and initializing it with 10. Now, does that mean that I overrode that previously allocated memory ntcats, which is at line number 2? No, I'm not overriding that. Okay, the data in line number 2 ntcats is not overwritten. This ntcats at line number 7 is in the totally different scope. Why it is in the totally different scope? Because the scope starts from the block, which is at line number 5. Okay, that is the scope. That's where the block starts, and that's where the scope of the new variable starts, which is at line number 7. So now at line number 8, I'm just creating another block. Okay, so I have another start of a block of left braces at line number 8, and then at line number 9 I'm creating or allocating the memory for ntcats again. Is that ntcats is going to override the previously created ntcats? No, because it is going to be in a totally different scope, because it is in a different block. The new block is started at line number 8. And then at line number 10, I am using a cout object to display ntcats. So what do you think? Which ntcats is going to be displayed? The ntcats in this case will be displayed is going to be from the line number 9. Okay, so it will display 30. At line number 11, I want to be able to display the global ntcats. Okay, so as you can see at line number 11, I have right here I have a scope resolution operator in front of ntcats. That tells the compiler at a runtime, that it will have to go to the outermost scope. Okay, there is no way to go to any other scopes. It will go to the outermost scope. In this case, our outermost scope is a global variable, okay, which is ntcats equals to 20. So that's what it is going to display, 20. And then at line number 12, I'm saying end the block. Okay, at line number 12, it is going to end this block. Now, as soon as it ends the block, whatever was in the scope at line number 9, that ntcats is going to go out of the scope. Okay, so the memory is going to be released for that ntcats. And then at line number 14, I'm saying to print out ntcats again. So what do you think it is going to do? Which ntcats is going to print? It is going to print ntcats from line number 7. Okay, because that is in that block, because line number 14 is within the block of line number 5 and line number 16. Okay, so that's why it is going to print that ncats, the value 10. And then line number 15, I'm just calling the show function, and the body of the show function is at this next page right here. Okay, and basically, as you can see, this is not part of the class. It's a global function, and all I'm doing is calling using a C++ syntax for the cout, and it is just going to be able to see this ncats, only the global ncats it will be able to see. It cannot see any of the ncats which are declared within the function. It can only see the global variables, or a global ncat. So now let's just give a little bit of a twist to this code. What will happen if I comment out line number 2? Okay, if I comment out line number 2, of course my code in this show function will break. Okay, so let's say if I'm just going to comment out line number 20 as well, so to make it compile smoothly, because as I told you earlier, the this ncats right here is the one which is a global one. So if I comment out this one, it's not going to be available. The memory is not there. But within main, the point that I'm trying to make is that I have this ncats at line number 11. Okay, at line number 11, the scope resolution operator in front of the ncats, which ncats it will print. As I told you earlier, it will always go to the outermost. Now, if I have commented out line number 2, then the outermost will be which one? Of course, the outermost will be at line number 7. So it will print out line number 7 ncats, which will be 10. Okay, so these are the basic scoping rules that C++ has, and I'm sure you will get used to them, and they are very flexible to use. And in fact, the purpose that they have given for mixing the statements and the declaration, the biggest purpose is that the people do not need to declare a variable way ahead of time until they actually use it. Okay, that's the whole main reason. So once you use it, you just use it, and if it's within that scope, okay, within that block, after using it, it will be destroyed. So who cares? So memory will be released, which is very good, because you don't want to allocate the memory for no reason for the whole life of a program. The main purpose that the global variables are not good to use is because they will take up all the memory. In this case, I'm just giving you only one global variable, but believe it or not, people use the global variables with 100 or 300 global variables, and as soon as you start the program, it allocates all that memory for those variables, okay, until the program ends. So that's the one big reason that it's not a good idea to use a global variable. Besides that, the global variables can easily introduce lots of different bugs. Okay, so please avoid the use of the global variables in C++ code, because there is a better way of doing it. When we go and start understanding what are the static data members and static member functions, that's the time we will talk about it. Okay, so it has very alternative ways of utilizing the same concept by narrowing it down that will belong only to the class, and we will discuss that in some next lectures coming. Okay, so basically the output of this program is going to be as follows right here. Now let's look at the scope of a variables within the for loop. Okay, how the scope is declared and how the variables are declared within the for loop. So in this example, again, the example starts with the header file IO stream and then the main function. It's a very small, simple example. Okay, and I have a one for loop in here. So notice that at line number 3, the for loop starts, and within the parentheses of the for loop, I declare the identifier. Okay, I equals to 0. So I'm declaring and initializing the variable at the same time. Okay, and then I also declare another variable j separated by the comma. Okay, and that is initialized to 10. So this is how you basically declare the variables within the for loop. But you cannot declare two different types within the parentheses of the for loop. You are allowed to declare only one type. If you want to be able to declare two different types, then you will have to go with the old way, like the way that C does, and have the declaration of the variables outside the for loop and then use them within the for loop. Okay? Now, the point that I'm trying to make right here is that what is the scope of I and J? Okay, declaration is done, you understand very easily. What is the scope of the I and J? Okay, how long the scope lasts? If the statement comes right after the for loop, okay, the scope of these both variables will go away right after line number 4. Okay, so they go out of scope, meaning that if I do the C out somewhere like 4.5, line 4 or 4.5 or something, then that I and J are going to be out of scope. That means I will see the compilation error because it won't find those variables declared anywhere. Now, in earlier versions of Microsoft Compiler, there were some bugs. Okay, until I think a very early version of their like in 6.0 compile C++ compiler 6.0 and .NET very early version. So what was the bug actually? The bug was that the scope of these variables will stay even after the first statement, after the for loop. Okay, so the scope of I and J will still be right here. Okay, that's a bug. And why it is a bug? Because it can cause some problem with the data members declared within the class, okay, and overriding these values. So, but now they have fixed it. I thought that if you would be using an older version of Microsoft Compiler, you will have to watch out for this bug. Okay. So now other way, if you have multiple lines of statements for the for loop, so that means you have a start of the for loop with the curly braces right here, and of course end right here somewhere, so basically within that, then the scope will stay with the multiple statements. Okay, for I and J, then the scope will be there because we created another block right after the right parentheses of the for loop. So once you compile and run this program, this is the output right here. Okay, let's look at another example related to the for loop. In this case, it's a nested for loop. Okay, so again the example starts with the include the IO stream. And then since it's a very small example, it's in the main function. And I have a for loop, nested for loop right here. So at line number 4, I have a for loop starting with declaration of n rows. Okay, int n rows. So n rows are declared, that variable gets allocated. The memory is allocated for this variable, and that memory is initialized with a 0. Okay, and then since as we talked earlier, there is a block right here in this case, so the block means it ends at line number 9. Okay, so the scope of n row will not only be a one statement after the for loop. Okay, it will have a multiple statement, as many as right here. So if I do the C out right here for n rows, the n row still will be in the scope. Okay, it still will print whatever the value that the n row has. And then within this for loop, alpha, okay, alpha has a scope until this line. Right after this line number 7, the scope of the alpha is gone. Okay, so alpha goes out with the scope, the memory is released. So once you compile this small program and run it, you will get this following output. Now, as you can see at line number 6, I am initializing A. Okay, when I create the alpha type, I initialize that with A, which means 65. Okay, and then I'm comparing it with this A, which is 65 plus 6. Okay, so until that this becomes false, it will be keep doing it. Okay, and that's why you see this 65, 67, 68, 69, 70, and 71. Okay, so basically when it turns 71, it will stop. So this is an end of chapter 1, and next chapter we'll start will be chapter 2, that will give you more understanding of how the member function works, and also main thing will be namespace. And of course I already told you that the pointers and understanding of how the member functions sees the data member directly. You don't have to declare an object within the member function. So all those things are the one that we will be covering in chapter 2. Okay, until then, we will see you later. Thank you.